will take it now from all the great evidence and facts to maybe some more methodological questions about the European Union policy making. I guess in Brussels we are somewhat in a paradise for evidence-based policy making compared to national policy making, which is much more political. So as the Coalition for Energy Savings, we definitely fill this space, and we feel very comfortable in working on with these facts, these figures, what is provided by the Fraunhofer Institute, by the IEA and many other consultants. But I think it is about translating that really into the better regulation agenda, into the whole question of impact assessments where not everything is going right at the moment. So what I'm going to present to you is findings from work we have been doing with Ecofis, the research consultancy. Somebody mentioned already not published yet, that's true, but it will come soon. So you're going to be also the test audience now, and looking very much forward to your questions and comments on that. Who we are, the Coalition for Energy Savings brings together a broad alliance of stakeholders, businesses, civil society, trade union, workers there, as well as local governments, really cutting across the different spectrum of the energy efficiency value chain and its multiple benefits. And we are now working together over 6 years, really leading the battle for placing energy efficiency at the top of the energy and economic policy making in Europe. Now, why does the impact assessment methodology and all the work around modeling really matter? That is because when you look at the different institutions, what they've put up as their ambition level for 2030 is a huge range. We have the European Council who said at least 27% for 2030 in terms of energy efficiency. The Commission said at least 30%, and the Parliament said, well, it should be 40%. And everybody says we've got the best ambition level, cost-effective, optimal, and I think we need to really explore how this can happen, how such diverse, wide range of ambition levels is out there, and everybody claims they have got the cost optimal, effective, whatever result here. The difference between 27 and 40 is huge. It's about an ambition level, considering that in terms of MTUEs, million tons of oil equivalents, in 2030 of 250 million tons of oil equivalent savings here, which between 27 and 40%. That's the energy consumption of France, primary energy consumption. That's worth around 500 billion euro investment. So it's a huge difference in ambition we are looking at. Also, in terms of policy making, the signal is very different. 27% is more than probably the business as usual projections, but not much more. It's not doubling. It's not anywhere close to the projections and scenarios we have seen in the presentations before. It's sort of marginal changes, stepping up maybe some policies here and there, but nothing fundamental. While a 40% efficiency target for 2030, that sends a very strong signal. That's about, yes, I'm motivated. I have to get really my hands dirty now into energy efficiency on the ground, in mobilizing the investors, the actors, changing market designs, taking down barriers. That's really about doubling or even more the energy efficiency improvements. So that's what we have to keep in mind. That's where we are coming from. And looking into what happened in 2014 with the European Commission impact assessment for the 2030 energy efficiency targets, we find that it's actually a least cost analysis. What are the costs of reaching a 40% greenhouse gas target? It's the cap. We don't want to go beyond that, so the efficiency policies should just sit in there. And though big changes in policy designs and market designs, the barriers are maintained. And so it's a least cost analysis given a given climate target with given climate policy instruments, particularly the ETS. That's also not just a least cost analysis, but it is based on a private perspective. So looking at the private interest in that, that's private interest rates, which represent then the approach to costing the investments into energy efficiency, which naturally are short-term and give a completely different picture than when you would look at this from a societal perspective. Private interest rates is the same as private discount rates. A lot has been said and done already about discount rates, and we are building on that. Discount rates is the term used by the Commission's energy system model, PRIMES. It's actually misleading. It's not a discount rate, because discounting you do when you calculate net present values. It's actually an interest rate you use when spreading your initial energy efficiency investment over a certain time period and calculate your average annual costs. So the term we should use is actually interest rate, and I think it's much clearer than what we are talking about. Now, the discussion around discount rates, the analysis, the research done by several organizations also here in the room have shown that they are much too high. They are ignoring already policy impacts, taking down barriers, and that the Commission should reduce them. We're hearing news that they are reduced for the ongoing modeling work this year, from, for households, 17.5% to maybe 10%. In terms of households, probably also transport. But that is still a private interest rate. That's the private interest perspective you would have when you do a certain investment. That's still something else than public policy making and recognizing the role of public policymakers in actually changing market designs and changing, therefore, also the private interest perspective. So what we can conclude from that analysis of the methodology the Commission is applying in its impact assessments is that it's partial and it's not sufficient for public policy making and not in line with the objectives and principles put out in the Energy Union, which gives energy efficiency a priority place. It's one of the pillars of the Energy Union, and for the energy efficiency first principle, which Commissioners Cañete and Šefčovič and other politicians are raising as their principle, as making sure that in whatever they do, whatever they are planning in terms of investments and energy policies, that first they have to and should look at energy efficiency and the savings potential. And of course, it's about, and I mentioned that already, better regulation policy. This Commission took this at a quite high level, coming out with a big package, better regulation package, including interinstitutional agreements to make sure also the other institutions, the Parliament and the Council, do follow evidence-based policy making, transparency, etc. And in this better regulation package, you find guidelines for how to do impact assessments. And they are quite specific and clear about what you should best do in terms of assessing the impacts of public policy making, and from that we can conclude that in the case of energy efficiency 2030 targets and policies, one should take a societal perspective and one should apply a cost-benefit analysis, given that there's a quite wide range of data available in different models, and that it's about really the appraisal phase. It's not yet about the detailed design of policies and what's then maybe least cost, but it's really talking about what's actually the ambition level, are we really motivated, how far are we motivated to do energy efficiency. Right, so with the study, that's the background. With the study then with Ecofis, we are trying to move towards such a cost-benefit analysis. I have to say this is very limited and based on the data the European Commission is using for its impact assessment then in 2014. What is happening there is we simply take the available data and apply a societal perspective, a societal interest rate instead of a private interest rate, with the same numbers on the energy efficiency, direct investments, and capital costs. And here you are. That's the result when you do that. You have, first of all, here the different annualized cost and benefits compared to the reference scenario, which is the greenhouse gas 40 scenario in billion euro per year in average. These are the different scenarios: 25% energy efficiency compared to the Prime's 2007 baseline. That's the reference. That's what you need, 25% energy efficiency at least, in order to get to 40% greenhouse gas reduction, giving a 27% renewable share. So that is the original curve from the impact assessment 2014 under a private perspective, including the upfront investment and capital costs for energy efficiency. So that's this red curve, steep curve. What happens now if you apply a societal perspective represented by an interest rate of 4%? You drop that curve here to this level, so much lower. And in addition, we found out that the assumptions taken by the Prime's modeling about the lifetime of investments is maybe on the lower end. It's about 15, 20 years, which is assumed technical lifetime by the modeling by the European Commission, while we know that for many investments you have lifetimes beyond 30 up to 40 years. So here 20 years is applied and the cost curve would reduce further. Now that is compared to one benefit here, financial benefit, that's the energy bill savings, which is stable because they are not discounted this year. Each year reoccurring saving you have, they are not discounted in primes, nor we have to do any changes here. So you see it's a huge change. Before we had a crossing over point here where we have a zero benefit, zero net benefit in the original model, in the original impact assessment of 27%. That's what then the European Council happily chooses as the target. And that is moved to beyond 35 and even beyond 40% energy efficiency, just by changing the perspective from private to a societal perspective. Right. Further to that, we tried to compare with the cost-effective energy efficiency potentials as we have seen them from the Fraunhofer Institute together with other research institutes done for the European Commission, which came to around 40% energy efficiency by 2030 being cost-effective, delivering net benefits for the individual investor. By trying to compare that, we had to look into the different sectors, and there we realized things become very messy. So this is a part which I think requires further work. But what we want to show here is clearly that the whatever color that should be, lila, purple, we have in the impact assessment by the European Commission for the energy efficiency 30 to 40 scenarios, nearly no change in the savings expected in the transport sector, which is quite bizarre, while the Fraunhofer Institute for the high policy intensity and the near economic scenarios assumed a much higher contribution of transport sector in delivering savings. So basically, if the Prime's model has difficulties in building in the cost-effective transport saving potentials, then that is really a modeling problem. It means also that if we would look into that, the Prime's model should achieve much higher energy efficiency scenarios than it does currently. The limits of our work, this is just an example for a cost-benefit analysis. Many more things have to be considered for cost-benefit analysis in terms of impacts, of course. This is just financial energy system impacts. Impacts which have to come in here concern regulatory activities, of course, multiple benefits, and just we provide a little example of the many benefits which have already been quantified by different studies from job maintenance and creation, GDP impacts, gas imports, air pollution, health, where studies have provided numbers and would be a starting point to include those in the cost-benefit analysis. And of course, the limitation I mentioned, just working with the current primes model seems to be underestimating certain sectors' potential and therefore not providing a sufficiently ambitious outcome compared to bottom-up models like the Fraunhofer model would give us. Right, so these are the findings, which I think could play an important role in the ongoing work assessing the impacts of different energy efficiency ambitions and scenarios right now developed and being the fundamental input to all other policy proposals this year, be it the effort sharing decision, be it the renewables directive after 2020, and of course the energy efficiency directive itself, which is expected to be presented after the summer together with the energy performance and buildings directive. Probably we are a bit late with pointing out these difficulties. The Commission is quite advanced in its work. I think what we should expect is that efforts are made to provide this alternative picture alongside the impact assessment work. This is about opening up a space for policy making, allowing with a cost-benefit analysis to make energy efficiency an policy and objective on its own merit, and actually providing the space for whatever then you have in terms of a climate and climate ambition discussion following. Obviously, working with a constraint of a 40% greenhouse gas as a modeling cap, that whatever energy efficiency you do, you must not go beyond that for political reasons, is not attainable. That is definitely the worst which could happen for energy efficiency. I would fail to give it the priority role and to recognize that principle of putting energy efficiency first. Thank you.
We have time for a few questions, and there was one microphone down there. So,
thank you for your presentation, Stefan. I'm Michiel Heckenberg from ECN Energy Research Center of the Netherlands, and I highly applaud the effort to put a societal perspective on cost-benefit analysis in such studies. But I'm wondering, or at least a bit concerned, that you seem to do this for the investment side, but not for the benefit side. And could you say something about that?
So there are further limitations, I said, in this work. First of all, we would need to consider that in these investment capital costs as well as energy bill savings, you still have the impact of taxation in there, VAT and other things, which in a societal perspective you should take out. These data are not available within primes nor other studies, so the understanding is the direction is similar. If you take VAT out here, you drop that curve, but if you take VAT out of the direct energy efficiency investments, you reduce that curve as well. So to be seen where the landing point would be, this requires changing the data set. Number one. Number two, on the energy bill savings, where you noted that this curve would also eventually change. This is not the case because primes simply provides average annual costs and benefits. And since the energy bill savings are per definition annual, because they They're not like an upfront investment which you have to then spread over a certain time using an interest rate. The energy bill savings occur as you go, so there's no need to change those.
Especially because energy taxes in some countries can be quite significant. Also, it's not only VAT that drops both lines, but energy taxes only drop the benefit.
Same with income tax or whatever you have on the, direct investment side.
And then a question from Richard.
Richard Cowart, Regulatory Assistance Project. A comment first for Stefan, and then a question for Jakob. Stefan, when in your first slide, you use the term least cost analysis. And I think what you really mean is least first cost. Because as the phrase is used in many places, least cost analysis would include net benefits, and your argument is it's only the cost side that's being considered. So I suggest you just change the term. The question for Jakob goes to the statement that you made a couple of times that in order to induce savings in industry over one of your scenarios, you would need a carbon charge of 70 to 75 US dollars or something like that. I didn't quite understand that. One of the reasons I'm saying this is that RAP has done a lot of analysis demonstrating that if we were to strategically invest carbon revenue in assisting end users to reduce their bills or to improve their technology for a lot lower carbon charges, we could accelerate change at end use levels. So I've just wondered about what you were really saying there.
Yeah, sorry, I wasn't completely clear then. If it was, I didn't talk about a carbon tax or so. It was just that we divided the cost savings by the total emissions saved to show how much cost do you save per ton of emissions that is saved. So it may be the case that on average it costs you, when you look at the net costs, $40 per ton of CO2 in the energy intensive pathway, and when it's $70 less, then it means that you have a benefit of $30 in the energy efficient pathway.
I understand your answer now, I think, and I would simply urge people to think about the strategic ways to use carbon revenue to do even better than that.
I understand you already touched upon this, but just as a quick summary, what in your view are the key obstacles to attracting greater investment in energy efficiency?
Well, let's start with a big policy question, which is about the outlook 2030 missing. In the EU, definitely, some countries have at least put in place now a 2030 perspective for energy efficiency. So when we, for example, looked into the Energy Efficiency Directive implementation, Article 7 in particular, which has this unfortunate sunset in 2020, then it's clear that in terms of public policy making, support schemes put in place, efforts to take down barriers, market barriers, that this 2020 sunset is sort of limiting what policymakers are doing in order to changing the environment, and then of course the investor's perspective. So maybe that's the key, I would say.
Isabel Vincent from ADEM. One question to Jakob. You choose the metrics for comparing the two scenarios, being the difference in investment and O&M costs for the energy sectors. But then wouldn't be the right metric be the impact on the GDP of these two scenarios, taking into account the effect of the trajectory that you're taking on other sectors of the economy, and then seeing whether you get increased growth or not, independent on whether you save only on the energy sector from a rather static perspective. So that was my question to Jakob. And just to Tyler, I was just a question to ask whether he really thinks that we're going to make the half the way through efficiency or also through sufficiency.
First of all, we calculated also the savings compared to the GDP. I just didn't show them, but you can find them in the report. And a second point is that we looked at different developments of GDP and compared both pathways, but we saw that the results don't depend a lot on that, because both pathways profit from a higher growth of GDP or the other way around. But what we not did is, and what would be out of the scope of the study is to look at the impact on the scale of the full economy.
The macroeconomic impact.
Hmm?
The macroeconomic impact.
Yeah, the macroeconomic impact of this energy intensity studies, because this would require a much more detailed, or a very different model actually, so a macroscopic model. Yeah, this might be something. I think too that it's interesting, but it was out of the scope of the study.